This is where some of you have some small questions. We won't spend forever on this because, ladies and gentlemen, yes, this is archaic. The problem with solving by graphing is because there are too many ways, there's too many things that can go wrong that you can't be, graphing can only be so exact. You can only get, maybe your line's got a little crooked, maybe your whatever. It is not a very mathematical way to do this. So here we go. Lucy, give me one. Number 15. Hold on a sec. Let me do a little. Yeah, 15. Yeah. Here is what you can see with problem number 15, and I'm just going to do this ill-advisedly freehanded. But if you're graphing both of those, I actually do have a graph I could pull up. I should do it. But first of all, one must speculate what is the graph of y equals negative 5.5. No matter what x is, y is always negative 5.5. So you are going to get the graph of a y equals line is a horizontal line always. The graph of an x equals vertical. So here at 1, 2, 3, 4, 5, 6, here at negative 5.5, you're going to get a straight across horizontal line. The other one, again, this is why graphing is really not your best way to solve this. Today we will do a different one. Standard form, solving it by x, y intercepts. If you cover up the y, x equals 22 divided by 4, which is 5.5, right?
Yeah.
Crosses the x-axis at 5.5. 1, 2, 3, 4, 5, 6, 5.5. Crosses the y-axis at, this is negative 22 over 4, which is a negative 5.5, which lo and behold actually ends up being that exact spot right there. You do that, the answer is there at 0, negative 5.5. Please stop. Please stop. I prefer mine. Yes, Conrad? Huh? 16. Let me find number 16. Ugh. Let's see what 16 holds in our future. All right, so again, I will do this as best I can on some sort of a, I thought the last one worked out well. All right, these are both in standard form. It's going to be ugly, but let's do it anyways. Maybe you'll touch this, maybe you won't. You know, do I bother this?
No.
Look, Conrad, when you have this is not going to be an easy thing to do in standard form. But if you solve it for y, you turn it into slope-intercept form, which should be maybe easier. So if I solve this for y, which would end up looking like this, watch, and I am going to subtract my x to this side, so I end up with negative 2y equals negative x minus 1/2, right? And then to solve it for y, I can divide by negative 2, divide by negative 2, divide by negative 2. Well, this is 1 divided by 2, so it's actually 1/2 x. It's positive because they're negative. This is also going to be positive because it was a negative divided by negative. How do you divide by 2? Well, it's the same thing as multiplying by 1/2. So you get positive 1/4. I don't know if that made any sense to you, but that's what you would get. And that is in standard or slope-intercept form. Crosses the x or the y-axis at 1/4. 1, 2, 3, 4. 1/4 is right there, unfortunately. And it has the slope up 1/2. But you're going to say, how do we go on 1/2 from there? Well, here's up 1, 1/4 of the way there, over 2, put up 1.
Wow.
Over, I know, Here, you get a line that looks much like that.
Somebody give him $1. Right, brother.
The other line, I guess I'll solve this standard form. Cross the y-axis at 2 divided by 8, which is negative 1/4, which is right here. I don't like that. And crosses the x-axis at 2 divided by 4, negative 1/2, which looks like it's right here. Now, I'm going to tell you, I have zero idea what that point is other than it's a couple of fractions. Negative 3.5, negative 3.5, was that what it was? No, what was it? What was the answer to that? 16 was negative 1/2, 0. Oh, I guess I was close there. That wasn't bad, was it? Now, if you had something close to that, I'm not going to split hairs because, like I said, this is not the way you ever want to solve systems of equations. There's by far much better ways that would make it much easier. This is the book just trying to show you how not to do it. Because you will be forever changed not to. Now, let's forever change your life. Are you ready to forever change?
Yeah.
We have to keep going because otherwise Anna will expose every letter of the alphabet out of your little Ladies and gentlemen, today we are going to solve some systems of equations by drum roll, please. Remember, your homework is ever increasing with every extra little thing, David, you put into this thing. I kind of like it better when you were sick. Bye.
Hug it out.
All right, by substitution, ladies and gentlemen, take a look, see here. Let's see if this makes any sense. If it does, then I don't know what to tell you other than, do I have two of these open? Because it doesn't seem like I have the paper here. Oh, ladies and gentlemen, here we go. Now, what I would put under substitution is this. In order for you to do this, in order for you to solve a system of equations by substitution, one of the equations must be solved for a singular letter/variable. I will explain that in just a second. Why don't you write that down? In order to use substitution, because believe it or not, there's another way to do this. I will talk about that later. In order to do substitution, one of the two equations, or both of them, it wouldn't matter, but at least one of them must be solved for a singular letter or a variable. That means this. Let's take a look at the examples I gave you. See this one? The letter y is by itself. That's good, because you need at least one of them to say y equals something or even x equals something. This one over here, y is by itself. This one down here, now hit the proverbial wall here. This one right here, I think I need to be calibrated. Who wasn't that calibrated this morning?
Me.
Thanks, David. This one right here, where'd it go? Sorry. Number 3, ladies and gentlemen, boo. Oh no, what am I ever going to do? If you come across a situation where neither one of those are solved, you can easily fix it because you are master of your own domain. I just pick, see this X, Y, they're kind of by themselves, but they're not by themselves. I just need to move one of these two letters over there and then I'm good. In this case, which one would be the most logical one to solve for what? I would probably solve this for x because to solve for x, I would add the y that would become positive. If I subtract the x, I still have a negative y, and I don't like that. So before I even started this problem, I would just do this, add y, and add y. So x would equal, I would put it as y minus 2, which is the same thing as negative 2 plus y. With that same thing over here.
Oh no.
Which one would be the logical thing to solve for what there? Not subtract the y. Subtract the 5x because then the y is by itself. If I subtract the y, I haven't done anything except create one problem. I would subtract 5x, subtract 5x. So now y equals 7 times 5x. Okay, so that's the first step. That's really not how we solve these things. Here you go. There's a reason why this is called substitution. Would you like to know why?
Yes. I would.
Because you are substituting. And this is the way it looks. This is just as easy as this is. If I know that y equals 4, if I know that y equals 4, then any place I see a y in the other equation, I can put the number 4 in because they are equal to each other. So I'm going to take this little 4 and substitute him in for the y right there. So that equation would look like this. I have the minus x, the plus 4, and that plus 4 gets multiplied by whatever the y was, which was 4. And that equals 10. I am simply substituting what that thing is in the other equation. And then solving. Negative x plus 16 equals 10. I would have to subtract 16, correct? Negative x now equals negative 6. What does positive x equal? Divide both of them by negative, or however you want to do it. X would equal 6. Am I done?
No.
Not yet, because remember what I'm looking for. In any system of equation, you are looking for the place you graph those two lines where they would cross. Y equals 4 would be 1, 2, 3, 4 right here. Graphing this one, you'd have x crossing at negative 10, which would be way over here, and y crossing at 2.5 or whatever it is, which would be like here, and then you're going to get a line that looks like that. You are looking for the place where this dot is. So you have the x value. You have to find the y value. Now, how do you do that, you ask?
How do I do that?
Well, this one, it automatically tells you. You already know what y is y.
4.
4. But if it doesn't do that, so here, let me write down. Number 1, you have to substitute and solve. But you can't forget step number 2, which is you have to take the answer from 1, from step 1, and put that, I'll show you what this means in a second, into one of the two equations to solve the other variable. Solve other. You will see when we do the next one. In this case, I didn't have to because I already knew what y is. Y equals 4. So you actually write this out as the point 6, 4. That is your answer. Which it doesn't. I didn't do a very good job of graphing this, but it would end up being way over there. The graphing is archaic, and we don't want to do it. You got this down. Can I move on to the next one? Not today. This one is where they get a little more complicated. Okay. So here, again, you know what y equals. So you have to put this whole expression in for the letter y there, which means it's going to end up being a little distributive property. I have the negative x minus 6 times what the letter y, well, which was this, 4x plus 6 equals 4. Okay, you can stop. Let's go to the table. Please make sure that you don't substitute this in for the y in its own equation, because that will not end you up with anything except something that's not even solvable. You end up with 0 equals 0 or something like that. So you have to solve it in the other equation. Are you with me? I put what y equals in for the letter y there, and now I have to do the solve for that, which isn't too bad, I think. Negative x, negative 6 times this is negative 24x. Negative 6 times that is negative 36. That equals 14. Boy, this works out. What do I get if I put these two together? Negative 25x. Move this to the other side, so I want my x's by itself, so I add 36. Oh, look, this is going to work out nicely. 14 plus 36 is 50. And then solving I divided by negative 25, which is good. It works out. And they will work out. If they don't work out, you probably did something wrong. In the real world, they don't, but for today, tomorrow, we probably. So x equals what, ladies and gentlemen? Negative 2.
Yeah.
Is I done?
No.
I need to figure out what y equals. And here's the part where it doesn't tell me what y equals. I need to take, now that I know that x is negative 2, I need to put that negative 2 into one of these two equations to figure out what y is. Oh, great.
Yeah.
Okay. Now, would one of them probably be easier than the other? Yes. Which equation, if you had to choose, would you put the negative 2 into? I would too, because it's already solved for y. You just have to take 4 times negative 2 plus 6, which is negative 8 plus 6, and negative 8 plus 6, y also equals a negative 2. So your two answers are x is negative 2, y is negative 2. If you wanted to graph both of those lines, it's going to cross at negative 2, negative 2. How about that? Was that not fun? I'm going to think you're behind the 8 ball here, let me tell you. We have gone through so much stuff that it will just knock your proverbial socks off. Here we go. Let's try this one. Where'd it go? Okay, this one. I already did this. I moved my 5x, so I solved the y. Please forget about, you don't even need to think about this equation anymore because you changed it. This is the equation you're going to look at. Okay. You are going to substitute this, what y equals, you know y equals that, so I'm putting it in for the letter y right there. You're with me?
Yes.
Not with me here. So here, let me look slowly but surely. 15x comes from right here, plus 3 times what that y is. Here's y that I'm putting in for that. 3 times 7 minus 5x equals 5. Yeah? Yeah. You want to solve the rest of that, or shall I? Of course we shall. So here we go. 15x plus 21 minus 15x equals 5. Boom, boom, boom. Okay, what happens now, boys and girls? What is 15x minus 15x? Uh-oh, somebody say uh-oh.
Uh-oh.
I'll subtract those 21 over. What happens when I subtract 21 from 5? I get negative 16. Okay. I am now going to get x by itself by dividing by 0, which is can't do. So let's see if we can make some deductions. This is no solution, which means what about those two lines if I graph them? No, that's not what it is. No. Where do they cross? They don't. They're parallel lines. I divide by zero. I can't divide by zero. That means this is no solution. If you graph these two lines, they will be parallel. We should probably check to see, just to see if we're smart. Let's just do this real fast, just to see. How about this one? I subtract my 5x over, so y equals negative 5x plus 7. I just wanted it in slope-intercept form, just to make it easy. So it crosses the y-axis at 7. And what's its slope? Negative 5. 1, 2, 3, 4, 5. Negative 1 goes this way. Now, really, all you have to do is make sure that the slope of this one is also negative 5. But let's do it. This is going to get ugly. X and y intercepts. What is x? Where's across the x-axis? Not 3. 1/3. It's 55. Cross the x-axis at 1/3. Cross the y-axis at 5/3, which is what? 1 1/3, whatever.
Yes.
And guess what?
What?
Are you kidding me? Parallel.
What's that?
I am about ready to let you try it. Is that not the right one? I'll let you do that.
No.
You need to put this in for the letter X, because that's what it equals. X equals that. Put it in for X and see what you get for your answer. By the way, your answer will be a Y answer. Why? Because that's the variable that's left. As opposed to the variable that's right. Uh-oh. I just say, are you struggling? I don't think you should struggle. It's solvable, isn't it? It didn't say soluble. I said solvable. Like, oh, it's what? Did it work out? I just want to know where your line goes. I don't like the way people are looking, staring at this. Please tell me, David, you have something. Anything. Numbers. Again, this is something you want a big piece of paper to do because there's plenty of places where your unneatness, Kavari, could get you in trouble. You need to be organized. Neat and ordered. Do you have an answer? Ike, anything? Connor, anything? What you got? Negative what? Negative 6, I heard, right? You said X was negative 8, Y was 6. Well, if that's right or not, I'm just gonna, anybody else come up with that? Ooh, we do have some answers there. Carter, check out what you got. How far did you got?
Yeah, -1 and -5.
-1.5. Listen, who knows what happened? Let's take a quick gander. That's that much time. So I'm putting this in for X. So 7 times Y minus 2. Yeah?
Yeah.
Minus 6Y equals negative 20. That's what you should have started off with. Doing a little distributive property, 7Y minus 14 minus 6Y equals negative 20. Combining 7Y minus 6Y, oh, look, just gives me a simple Y, that's a good deal. Add 14 to get it to the other side, add 14 to the other side gives me a negative 6. Looks like a wiener meat. Okay. Now, that's why I have the answer. You have to figure out what the X is. And again, I changed this one. You could put negative 6 for Y right here. It's going to be kind of messy. I would put it in here because you already solved for the X. Just put negative 6 in here. Negative 6 minus 2 is in fact activate. So, ladies and gentlemen, congratulations and kudos to the lucky winner who did put that on. So bad.
Easy peasy.
I don't do this. Okay, not like this tomorrow. This one. Because I do want, before you get to into this year, to get a little practice at doing a few of them. Because I can tell you're excited about this. Indeed. Give a few of these to your college son. I would say you want to do this on the big. How many squares on the big paper card? 12 of them. Oh, look. There are 12 problems, but I'll say just do 1 through 10. 1 through 10. See if you solve a system of equation by staying focused and organized. If you have any questions, I would say you might want to talk to Ray. David.
What?
And raise your hand because you're like, you have a question?